that's something that humans are bad at, right? We're super biased and like anchor on to certain, thoughts of approaches, as well as like we get fatigue, right? Like trying to think of, oh, what would be a new possibility? What would be a new possibility? That's something that humans are bad at. But language models, one of their best use cases is like, what do you think you can do with something that you can just like throw, an infinitely parallelized like form of producing like differences, throw that at a problem and see what happens.
Thank you so much, Markus, for joining us. Super excited to have Markus today here with us. Markus actually went to college with me and was, I think, the year above me at Penn. But maybe, Markus, you want to introduce yourself really quickly and how you got here?
Hi, yeah. I'm Markus. I did Penn for undergrad as well as a master's focused on deep learning back when AlexNet kind of came out. My research was focused more on time series modeling and how to separate concerns between the image domain of the input space and the time series domain using basically a recurrent neural network combined with autoencoders. Since college, I had kind of worked on a couple startups. One was kind of like turning my master's research, which was how do you make an experimentation platform more responsive and get a better feedback loop, and turn that into a way to let people who don't have expertise in machine learning actually build and experiment with these models, starting with kind of like making it easier for researchers to experiment, but then ultimately like anyone, designers can play with it, hobbyists, tinkerers. That company was called Lobe.ai. We kind of made a visual interface for building these models, really focused on how to curate the best data set for the best outcome and let you interact with training live while the model's running, and you can really play with it and feel like you're teaching a computer something. And that was eventually acquired by Microsoft in 2018. I spent a couple of years there as the program manager for Lobe, and then left in 2022, I think. Yeah, and have started another company since then to solve some of the problems I saw around communication inside of a large organization and finding information.
Super cool. I mean, I didn't know that that Lobe was actually focused on the data curation side of things as well, which is interesting. I'd actually love to hear a little bit more about maybe how you've seen ML shift, because I really feel like you were there doing ML before all the Gen AI wave, and so a lot of things have obviously changed from then to now. Some of it is probably still applicable, but seems like a lot has also changed over that time.
Yeah, it definitely feels like the situation where history, rhymes, where the previous deep learning wave, there was a ton of hype and people were able to start getting into building companies and products around the new technology. And the number of people building just like with a technology without a problem in mind is kind of similar to now, where it feels like people are just kind of like throwing language models at things without necessarily a problem in mind. And the barrier to entry is even lower nowadays, so there's even more people working on it. But I'd say the overall kind of like paradigm that has remained the same is that data is everything. Any time you have a really large model, and that's what deep learning really enabled, is training really large models on vast amounts of data and it just getting better. What you curate as that data set is the most important part, and how you actually make a model behave. And because it's only ever going to encode into its parameters things that are likely to make that data set more successful in whatever loss function you're giving it. So I'd say that's really the main commonality. But as far as people like coming up with companies around this technology, it feels very much the same as it did, 2013, 2014, where, there's new exciting stuff. It's improving, every week, every month, and people are just trying out all sorts of crazy ideas.
I'd love to hear a little bit more about what it is that you're working on now, and how you got to the current idea.
The current idea came around from seeing inside of Microsoft, it's hard to find information across like all the different toolings you have. This is the same problem that kind of Glean tackled from a search standpoint, where you have a bunch of integrations across all your work tools, and finding that information these days with language models, it's better to kind of create a more semantic-based index rather than just kind of like traditional BM25 or keyword type searching. But I'm kind of like taking that one step further, where search is still a technical skill, and I've really found this inside of companies where your best employees are ones who are able to actually utilize search and actually find that context to get what they need. Whether it's pre-reads for a meeting to make sure they're running something successfully, whether it's finding context around a task they're performing, if they're an engineer, what customers have the problem that I'm about to like start a feature around. That really requires a lot of proactive usage of search and knowing kind of like the intricacies of where it works and how to like finagle the terms you're doing and spending all that time. So instead of requiring a person to have that skill, I'm kind of like turning that on its head so that you have a system that is using language models and kind of like an agentic loop to do searches for someone based on what they currently have in their task pipeline. So, integrates with a calendar, can see if events coming up, can already give you that pre-read based on conversations that are happening in Slack, previous notes in Notion or Salesforce, do LinkedIn searches, that type of thing. Or if you're an engineer, you have a task in Linear that just got assigned to you and you just moved to the like in progress. It can bring in those other supporting documentation. It can bring in the specific parts of the PRD that's important. Or if you're an executive or engineering manager and you want to keep track of how teams are working, and normally it's a PM creating the status report that's up to date and then rewriting it in smaller bullet points for more higher up executive leadership so they can digest a lot of information. You can definitely just have a system that lets you build that dashboard that is always up to date, always notifies you, a new decision was made, a new part of the feature was launched, that is already reflected, and you can always trust that type of output. So it's something that takes this highly manual effort of someone having to do all these searches based on like the tasks they're going, and instead lets a language model and an agent-based system actually go and perform those searches for someone and provide that information in a proactive manner.
Yeah, I love that because it's working in the background. It kind of enables people to be superhuman. And to your point, it's like so much of knowledge work today is actually just like context switching across like a million different tools, and like you're not quite sure where to find something, and like that's actually what slows down your progress. I do see this as like it seems like you might be more pessimistic maybe about like AI agents operating autonomously, because this is more of a co-pilot type of model. I'm actually curious like what you think about that. Like it feels like people's viewpoints diverge a lot. Like on one hand, people are like, oh, like, we have enough, the LLMs are smart enough that if we just RL'd on and collected enough data on all the white collar work, we'd be able to automate all of knowledge work. And then there are people kind of on the way pessimistic side that are like, yeah, the AI agents in the wild are like really not working. I guess where do you fall on that? And like what are the maybe enabling technologies that would actually have to happen? Can we do it in the current architecture?
The way transformers work is that they're creating kind of mappings interconnected between everything that it sees on the input side, right? Like it's able to attend across everything that's on the input and then make a decision for what the next output should be based on that. We've done fancy training techniques with reinforcement learning to be able to kind of like give it a better loss function to learn how to essentially bias the output to perform useful actions, things like instruction tuning, things like producing reasoning, right? Like those were all trained in explicitly from the data set. However, the language model still only ever operates on that context window that it sees. So in terms of like useful, like super intelligent or like agentic, like AGI type things, it's really about the time scale of that action space it can operate in, right? Like, can you have something that's a really far horizon problem represented in an architecture that only works kind of like in a locality-based context window? And admittedly, they are getting much larger context windows. Like we're in the millions already. But kind of like that's really the fundamental limitation of language models that I think one of the key missing areas would be kind of like this piece of like memory that is something that isn't necessarily just working memory in the like text input, like actual token space, and instead something that's a little more useful in the representation space.
Can you dig into that a little bit? I'm actually curious.
Yeah. So for instance, something with infinite memory, right? Like recurrent models, RNNs, or even kind of like these state space models that got a little bit of popularity a couple of years ago. They have kind of like this internal representation that's just continually updated based on inputs as it's seen. there is no limit to the context window. You're at the end kind of like updating some internal representation of what the world looks like, essentially, and using that to then condition what's happening next. So, language models don't have that type of memory in place. In order to actually give them that jumping off point, you have to stuff all this information into the input tokens rather than have like this, actual mechanistic loop where you can update, say, the main hidden representation. So I'd say that's the major difference. And what I see for something that needs like super intelligence is really on this longer term horizon where it actually needs to kind of like update stores of memory, like essentially working memory of the world and its predictions of states in that world, and then operate from there. So I definitely see language models as being a large component of that because they are representing kind of a universal computer, but it's not kind of like to that level where you can have a really long time horizon, especially if the fidelity of that input, like if the unit, instead of just a token, if the unit, if we're going to like, image-based domains, if it's like, frames per second, yeah, you can't really operate on long-term horizon videos and stuff like that. So it's like, I think there needs to be some other mechanism that allows like reading or writing to kind of a neural memory system. Back in the day, there were ideas like neural Turing machine, DeepMind came out with way back when. That was popular for a couple months. I don't know if those types of ideas still would hold ground or have research direction, but I think there needs to be something a little bit further along to help with these long horizon problems.
Yeah, I think that's actually a great point, which is like when I talk to you, you're kind of like updating all the weights in your brain, and you're learning about what I said over time. And so next time you see me, you like remember to like Nina, blah blah blah, and you're kind of like connecting all those dots in your head. But when you talk to an LLM, it's kind of like it's like a brand new day, it's like a brand new baby. It's like the same weights, none of the weights have shifted. I'm actually really interested right now in this idea of can you do like real time or live RL in the real world that's like actually updating the weights. And I think like there's one world where you're like that's like super risky, like it could totally go off the rails really really quickly, but there's like maybe some lower approaches that are more, hey, like we'll only fine tune a portion of it, maybe we can like shadow deploy the model so that it's not, if it goes totally off the rails, it's not impacting production level results. Or maybe there's like a policy approach. I'm not sure if you've seen any of these, but it's like more of like a policy head that's just like an adapter to the model. So you're adding like a new layer as opposed to you're like updating the weights of the model underneath. But I don't know what you think about any of those. Like, are we any closer to getting this like internal representation that updates that you mentioned, or does it really need to be a shift in the model architecture?
I personally think it needs to be a shift more in the model architecture, but kind of like those techniques I'm not familiar with, kind of like those online reinforcement learning type training things. But I do know there are lots of perils in like how you actually choose the right function you're using for reward for RL. And, there's kind of this notion of like reward hacking that models can do, right? To get around, like find surprising ways to optimize that reward function that you design. And if it's something that's like you're trying to do online that you might be changing that reward function, I think there's a lot of caveats and perils that could happen to actually make training successful in that type of paradigm. So I would like that just elicits kind of like a little bit of a cautionary kind of mindset from me. But I think even with just RL training, right, like that's what we're doing on large language models to begin with, to try to make them more reasoning focused, more agentic, like actually perform useful outputs. And if it's just fine tuning the last couple of layers, that kind of defeats some of the purpose of RL, which is to actually imbue that style of intelligence into the weights end to end, right? Like you need kind of everything to work in conjunction for an output goal for a model to really be successful. Otherwise, it's going to be kind of competing on representations or even just destroying previous information that's learned. And essentially, what we see in some like fine tuning, not in RL standpoints, but fine tuning the outputs of language models actually degrades their performance in a lot of general cases because it is forgetting some of that generalized knowledge it learned through training on the original large data set. So fine-tuning is actually, unless you have end-to-end training, fine-tuning hasn't been that effective in more general cases. It's like only very specific if you're trying to essentially destroy a language model's previous ideas about what inputs should look like and really focus it on your data set. That's where it could work. But yeah, I'd say you really need to do things end to end and really, really be careful about what that reward function is. And people spend their PhDs figuring out how to appropriately determine reward functions for certain applications.
I wanted to go to the point you had earlier, which was around the data, and like data is still the most important thing. I'm actually curious, like, has the type of data that we need shifted? Because I think in the beginning we had, maybe like everything that we had scraped off of the web, and then there was like the fine web that we had kind of distilled and cleaned up a little bit on the pre-training side. Pre-training is kind of dead, and then now we had RLHF, which was a ton of like human annotated data for a while. And then the new RL loops, like what kind of has a nature of the data that we need to change? And then like maybe also, how do you think about synthetic data? And like, is that actually useful? There were some papers early on that were like, if you train it only on synthetic data, like at some point, like the model kind of implodes in that it's not able to have that many loops of synthetic data. But I'm actually curious, in RL, maybe, it's actually fine. And we've done tons and tons of synthetic data RL training loops, and it's actually totally okay. I'm actually curious, like, how are the types of data need changed as we move into the new training paradigms that we have today?
I'd say, at least for more useful outputs, the data is now, and using a language model as like an agent type domain has required a lot more fine-grained kind of not representations, but fine-grained intermediate steps to that final output you're trying to do, right? Like we're trying to train reasoning steps. We're trying to train these models to actually operate more autonomously on a longer term horizon. So what that means in this autoregressive loop where, they're producing something and that gets added back into the context, that means they need to produce these intermediate chains that are more likely to bias that model to get it into that space of having that final output be right? Like in the case of an agent, that final output being, maybe something is trying to return to a user, more generally, it's like, what is giving a higher reward in this RL training loop function. So a lot of the types of data, I'd say, like, they're collecting, and this is one of the reasons, like, there's a little bit of secrecy between the reasoning tokens that like OpenAI is using, right? They're not giving you those back in the API, that type of thing, is to try to prevent people from creating these data sets of kind of like what are those intermediate steps, so that you can then use that to train, a different language model to say, guide it along those same types of reasoning loops that were more useful in producing that final output, that final desired result that gives a higher reward. So I'd say that's kind of like the nature of training these days, is like, how do you most effectively get that high quality signal in your data that will eventually give that higher reward in kind of general terms. And I'd say with synthetic data, it's very true that kind of like we've seen kind of like mode collapse and these types of things where the model just degrades the more it's just kind of like insularly trained on its own synthetic outputs. But if you're coming at it from a standpoint of synthetic data set, meaning in an RL sense, like you can create environments that can in fact vary the data, that isn't just like model generated data itself, but the environment can change that somehow. That can introduce noise that the model isn't itself introducing. So that'll help kind of avoid these types of collapses. And that's why we've seen, I'd say, more in the like robotics domain, like the simulator to real type translations, like that works really well. They're all synthetic. Obviously, it's a simulation, but it's not something that is like 100% determined by like a model output to begin with to create that synthetic part. So I'd say that's kind of like the caveat where it works and where it doesn't really work. But as a whole, like it's still huge amounts of data you need. Even for like something like fine tuning, like the more data you have, the better. Like that's just how deep learning works. But it's also the more high quality data you can get, the much more efficient the training can be. And especially in these cases of these like long-term horizons where you need to like, you want to train like a reasoning chain, for instance, right? Like you want to have as many really good reasoning chain examples that are still diverse from each other, but still high quality versus literally just, random characters. That's not going to be helpful at all.
Okay, so like data sets that would be useful. Like, would it be useful then to get like all of the PhD level thinkers at the edge of like astrophysics and like all of their various domains, and then basically get like thinking and reasoning chains for how they approach problems. Like, what is the actual data set that you need to unlock better reasoning in the models?
Yeah, I mean that would help in the domains that they have good reasoning for, right? Like it's going to overfit to whatever types of chains that are being shown to it. Like ideally, you have a really diverse set of human kind of like reasoning chains, and maybe even try to like extract them in the wild from what people are talking about in different forums. I'd say that would be like the more diverse you can get that are still accurate, the better, because you're trying to find like what is the like boundaries of the system in as many different directions as possible while still kind of being correct. And that's something that it exists for any type of deep learning system, whether it's images or language models, where you're trying to really provide as much of a broad input space as you possibly can, just to cover like all the possibilities that it can see, and provide signal in those areas where it would be less confident in providing those outputs. So and that normally means in the case where you have fewer data points to begin with. So, since language models are trained basically on most text on the internet and books and stuff like that, so extracting reasoning chains from text from the internet is probably not going to be that helpful because it's already seen all that text in aggregate already. But extracting out reasoning chains in domains and areas where it might not have seen that much during its major pre-training phase, I'd say would be the most useful in as broad of a domain as possible. Like you're still trying to get as many kind of like diverse and different domains and viewpoints as possible, just so like when it eventually like finds a reasoning chain that's like starting to go maybe in the more like artist path, like how do people think about maybe the audio engineering, right? It's not going to necessarily follow a similar reasoning chain to someone that's like thinking about astrophysics.
And so maybe take an example like computer use. Are the click streams useful? And then the ultimate result that, a verifiable, you were successful, aka like, here are all the click streams, and then here's the final code? Or is like, are the intermediate steps actually not even that useful or important? Aka, if I just had the final output off the program that you wrote, or the, verified step that you had completed some workflow on the computer, that would be enough.
Yeah, it's definitely a lot more data efficient to have that intermediate results to make training successful. You can do just the RL environments on the computer use. I think with just the reward function of was the last thing successful. If that time horizon between what the task was and what the ultimate success was starts to get too long, that's where things break down pretty quickly, and where the intermediate stream can help. But it is possible to train these things RL end-to-end with just the reward function if it's a well-designed reward function, and it can explore the space for a really long time, right? Like being able to train for a really, really long time with a lot of parameters, it can learn kind of like it can find those click streams that were successful. But yeah, long horizon especially, and having click streams to guide like what is more likely to be a successful outcome to begin with makes it much more data. It basically like just guides that training process into already a better path towards like a minimum.
Yeah, I'm actually curious like what you think about maybe like model sharding. I'm not sure if you spent a lot of time here, but I'm actually really interested. So there's model sharding that happens that's just like mixture of experts, and it's like we just like randomly put some information into each of the experts, and there's actually like the purpose is to distribute so that you use each of the experts like approximately the same amount. I think that's like less interesting to me. Like I'm actually more interested in why is there not a way to do mixture of experts that's or like model sharding that actually separates facts or like knowledge, not like just rote memory from reasoning? Because I think ideally like you actually have a like super smart like reasoning model or something that has like basic understanding of physics in the world, and then it just like taps into these like knowledge bases that are focused on specific domains that are just like, here are facts. We kind of do this today with like the RAG flows where it's like, okay, like we just put it into the context, and like that's kind of like a way to fudge this. But I feel like the best would be like some separation of those, because it's like I feel like right now the models know like a lot of stuff about cats and dogs and like all this random information that it doesn't even need to operate. I'm actually curious. I don't know if you've seen any research that kind of on toward that dimension, but I've always thought that would be an really interesting space of exploration, and I haven't really seen anyone working on this.
Yeah, I agree wholeheartedly. Actually, that's it kind of sounds similar to actually what my master's research was in, which is how do you separate the concerns of what's easier for different aspects of a problem to break it down into ways that's easier for different architectures that are more tuned for learning that aspect to be more successful, right? Like in my case, it was image domain using autoencoders and then time domain using recurrent nets. Same thing here. Like you could have something that's learning more of like, what is the representation of language, a classic language model. And then the reasoning could be something that's a little more tuned for like these long horizon and like a memory-based system that's kind of built on top of and interacts with the main language model that kind of like learns kind of like base concepts. I haven't personally actually seen that I can think of any papers around that part of it. And I think kind of like this mixture of experts, like I don't have too much familiarity beyond kind of like a cursory knowledge, but that seems like an interesting way to think about it, where you can have essentially a mixture of experts where the kind of like different components are maybe slightly different types of architectures that are tuned for different purposes, and then they get chosen based on the needs of the current state of like where you are in the processing of your input to do something. So that sounds like an interesting area that I'd love to see some more research in. But what I found and what I think generally people have seen is like end-to-end works really well when you have tons of data and a domain that is solvable by that particular architecture. You can be a lot more efficient with your data and have a higher likelihood of success if you're able to decompose the problem into specific parts that, the architecture is actually really well tuned for learning the aspects that you as the like engineer determine are the important aspects to learn, right? Like that's essentially how it goes back into like kind of like the human knowledge of how to decompose problems. It's the reason convolutional nets were really good for image classification is because we specifically designed these kernels that are local and learn how to work with pixels on this like locally connected level instead of having just like it fed into a giant feed forward neural network, right? Like it's much easier to learn in the convolutional domain than just a feed forward domain. That type of concept can be applied to, I think, anything where you have people who are experts in what should be learned and know how to decompose it. If you don't have those types of ideas, it's still valid. And I mean, this is what we've seen with like language models, right? You can have one architecture and throw tons of data and training at it, and it can learn kind of like interesting aspects that you wouldn't have necessarily hand designed, like areas where it should have learned. But the fact that we're going towards these like modes of like, oh, I need a specific reasoning model. Oh, I need a specific like instruction thing. I think that is starting to go down the roads where people should start to hand design what type of math is good for reasoning architectures, what type of math is good for, memory type architectures versus just kind of like the interconnected relationships of your input.
I'm actually curious, like, what are your predictions for where things head in the next couple years? Like, how AGI pilled are you? What is your timeline for, automating maybe like a percentage of knowledge work? How far do you think we can go with the current architecture?
I think we can go pretty far with the current architecture as far as if you're able to give the language model the right context and that right memory system it needs to actually have the information at one time in the context to do the final task that you're trying to do, it can be successful. And I'd caveat that with appropriate feedback to let the language model guide what input it needs to get that output. And that what I'm trying to say there is like, a lot of these agentic loops work well when you have like some sort of automated way of giving it feedback, kind of like on a finer grained level than just like, was my output right or not, right? Like if you're in a coding system, having it write and run unit tests while it's developing, and it's able to go back and forth and say, oh, this test failed, I need to change code to this test failed. Like that's what I mean by the fine grained level versus like just having it produce the code and then, have you run the thing live in production and see whether it works or it doesn't. That's generally not a recipe for success. And same thing for like automating white collar jobs. It's like, what I'm doing now in WorkForge for this communication platform is like, how do you make the best index to give the language model that context of these other, concepts or tools that people are talking about, so that it can then produce that final output, whether that's a pre-read, whether that's, filling in details for an executive. This type of stuff is wholly dependent on the quality of the information you give it in that context. And so I think we can make these types of automations with these clever tooling around how do you get that input in, whether it's like a really good index using knowledge graphs created by language models, which is an approach that I've been exploring that works pretty well. Or if you have a way that can give it that fine-tuned feedback while it's performing the task with maybe a human in the loop. And it's like, hey, is this related to you? Yes, no, like real quick. That'll help guide the language model to get the input context to be higher quality. And that's all you're trying to do in these types of systems. But once you have that input context that contains all that information, that is possible to give the correct output, it will generally give that correct output. I think with training, especially, RL tuned for different purposes, can do many, many tasks as long as the information it needs is able to be given in that input context.
Yep. Yeah. I mean, I'd actually love to dig in with you a little bit on like modern agent architectures and like how you guys are because there's a lot of components and moving bits to this. Like one is the whole vector retrieval and the knowledge graph side of things and like providing that context. It's also like, how are you orchestrating the loops? There are lots of definitions. I mean, lots of things are being called agents these days, some of which are just like everything from like a function to, I use a state machine DAG type of workflow. What are you seeing? How are people architecting these systems? Are people doing like multi-step? Are people doing multi-agent? Are people using frameworks? What are you seeing, and how are you guys also architecting with the product you're building?
Yeah, I mean, just from the sheer, I think, accessibility of playing with these models, people are trying every approach for agents, right? Like you see swarms of like different specific. Swarms are basically just prompt libraries, right? Like it's like you have specific prompts for specific use cases, and you can have like a master router that picks which use case should happen based on what the input currently looks like. You can have a lot more basic ones that's just kind of like one overarching one that has the list of like all useful tools that you are trying to do in this kind of like loop in kind of like one go. And that has some success in certain domains as well. I'd say kind of like my approach is, how do you, it all goes back to like that reliability aspect of how do you more reliably get that input context to have the information it needs to solve that task. And more often than not, if you're stuffing a context with a lot of kind of like essentially noise by having irrelevant tools, like if you say have the master list of tools and for a specific part of your problem, you're not going to need like half of them, that's really just adding noise to the context, and that'll make it less likely to produce a successful outcome. So the more you can do to prune and guide that context to be really, really high quality to whatever output you're trying to do, I'd say that is the probably the number one key for getting reliability in these systems. And so my approach has been kind of like utilizing language models plus other traditional, architectures that happen in normal computer science, like graphs specifically, and using kind of like properties of these systems together to guide how to give the best quality context of the input. For instance, when you have a graph of, language model, a language model produced graph of knowledge, like, you have your entity representation, you have the relationships between these entities. You can actually run personalized PageRank on top of that graph structure, and that will give you from some, say, starting entity nodes, like, oh, I want to find everything that's related to Nina. Like you can use your person's entity node as the starting point for personalized PageRank and just go through this knowledge graph that's been created and actually perform better than RAG itself. Like there's a paper from, I believe, Ohio State University called, the method's called HippoRAG, and they're trying to model like, how does the hippocampus work for memory systems? And they use this is where I learned about this technique. And it works really well. It's like that combined with vector searches is much better than, any standard just vector search, even like a Raptor-based system, which is recursively summarizing things and then using kind of like the repository of different levels of summaries in its semantic search. That was already pretty effective. But once you have this way of doing things that isn't necessarily just a language model, right? You're using a graph. You're using like the fact that you can run, personalized PageRank on this graph. That's actually guiding the system to get a better context to produce a higher quality outcome. So the more tricks that you can do in your agentic system of like what output are you trying to do? Like how are you trying to construct that input context? The more you thought you can put into like, how can I make it much more reliable to get that context to be good? That's really where you'll see the most gains as far as success rate. And oftentimes that also means like, how can I get like validation of that output so that then I can make smarter decisions about what the input context should look like. And that's in the case of like the coding systems with having unit tests run pretty often, right? Like they're getting that feedback of like, oh, I need to change my input context, with kind of like the results of these tests, instead of like just coding in kind of like one like direction for a while, right? Like this is a way to have it again be like, oh, the direction I'm going isn't working, so I need to change something. And it's giving that in the input context by having the feedback from tests. So same thing, for other knowledge work, like if you have feedback from people and you send, you send some info to people and get it verified or not, that can help an agent that's working with them guide how to next produce the best context to maybe change that outcome, get the approval from a person, stuff like that. So I'd say, those types of loops are the most successful. And whether you use, a framework to build the agent or, you have a library of prompts, like at the end, it's all basically the same, right? You're just calling a language model with a specialized form of the context, whether that has a lot of boilerplate made for you or not. It's up to you how you want to actually implement it.
Yeah, and then I guess like on the tooling side, are there tools or frameworks that you have liked on or like are using for the knowledge graph or the vector search components of it, or any parts of the stack that you think like have been working really, really well for you guys? Or
I'd say
maybe everything's homegrown,
yeah,
which is cool too.
yeah, it's pretty much all homegrown except for kind of like the more core like actual vector database store, right? Like we use Chroma for the data for the vector store. For the knowledge graph, there are a lot of like useful Python libraries for operating with graphs, like NetworkX. Using that to start, but like I like to be more homegrown in these types of tools instead of like using something like LangChain or that type of stuff. So you can have a little bit more fine-grained control of how you precisely construct these types of inputs, and that's where it comes down to me is like I need to precisely construct the input context, right, to get a better outcome, and I need to have that fine-grained control over it. So it's really like I'm basically just calling language model providers with prompts in a state-based like code setup that I have, using some basic stuff like Chroma for the vector store and NetworkX for the graph stuff. But those are pretty standard, and give you enough control rather than kind of like giving away too much of the control to say a framework, so that you can't be flexible enough to really make nuanced decisions about how do you construct this input that you're ultimately going to feed that final language model call that gives something to a person.
And I guess like specifically on the retrieval side, like I think most folks, the first thing they'll do is like they'll spin up Chroma kind of like out of the box, and like maybe out of the box it provides semantic search, maybe it even has like some hybrid search functionality. Like what do you think are the biggest gains you can get in terms of the results and the search quality? Because I actually think like search is a very interesting space because it is actually very hard. The eval loops are actually kind of hard. Like trying to figure out like, oh, like is this a good search result? Like is my re-ranker actually doing what I want it to do? Are the results I'm getting relevant to the user's query? Like are there like quick wins, or like if they're trying to optimize their search stack, what are the first things that you would recommend people go to where they could probably get the most gains? Is it implementing this knowledge graph approach? I don't know if there are other directions you would recommend folks go if they've just spun out of the box just a Chroma vector database.
My kind of like software design approach has always been more like follow Occam's razor, right? Like always try the simpler and not complex solution first to see, if it's good enough for your use case, and then add complexity only when necessary. So I wouldn't necessarily recommend try to build a knowledge graph right off the bat. In fact, don't even try a vector search right off the bat, right? Or just try VM25. That actually is pretty high quality search for a lot of cases. You have a bunch of text just throw a BM25 at it, or just put it in Elasticsearch and see if that's good enough for the search case. But if you determine you're trying to do the vector search specifically, first, again, just start with normal RAG approach, which is chunk the document and embed it, and then just retrieve the chunks and try that. Because that's, these types of things are so easy to do these days with the tooling, right? Like you can, Chroma will give you, like, you can just feed Chroma text and it will do the embedding and let you just search with text again. So it's like, that's basically free. Once you start up Chroma, you can try a normal base RAG approach. Hybrid search is actually something we also utilize, where it's a combination of BM25 plus the semantic results. And we use reciprocal rank fusion to kind of like reorder them based on the relative rankings. That did give a gain. So I'd say try kind of like those approaches. But kind of back to your point about evaluation, that is like how you determine whether the approach was good enough, kind of like to your result. First, it's going to be the gut check of like, oh, I'm going to type in some search queries and get the gut check. But what I've seen people use for the most success, and what I also implement for RAG specifically, is a framework called RAGUS, which is essentially you evaluate kind of like a couple metrics that you can use a language model as a judge of the output to help determine the quality of a result. So you want to determine like factuality, right? Like, was the actual result produced true or not? Faithfulness, so that's going to be like, is this like actually answering the question that was given, like regardless of whether it being factual? And I think another one's around like, did the citations that you expect to produce the answer exist in the like citation form? So like, was the input context actually retrieved the correct passages that you thought it needed to retrieve? So that's less so, that's not the language model as a judge. But the other two aspects, you can definitely use a language model to help judge. And just have that set up as like, you have a data set of a couple, golden answer query pairs, and you run kind of like these metrics of faithfulness, correctness, and the coverage and factuality. So that's probably the best that you can start with. Set up that like a little bit of evaluation framework, a couple golden queries and answers. Start with not vector-based search, then you can just try normal RAG pretty easily, and then just expand complexity from there, because it can really explode. There are so many techniques, right? Like you can try graph RAG from Microsoft's like repo right off the bat. You can try to combine that with something like Raptor, which does the recursive summaries of your documents and then embedding those. You can try things like Hide, which is, instead of the query, you make like a hypothetical answer from the query and use that to then do the vector search with. So it's like you're trying to get your input to look more like that repository of outputs that you're trying to fetch. There are all sorts of techniques, but it's really, I really recommend following that design principle of like, only add complexity if your current approach isn't meeting that bar, and the complexity adds a meaningful lift, because it's just adding more code to maintain, and any added complexity can make things more brittle. So that's kind of the approach I take.
I feel like the search actually could be its entire business. Like Elastic is huge, Algolia was really big. There's have been some pretty big outcomes in the search space, and it's also like most teams don't have a search expert on it. I think it's actually a really interesting space if you can build a solution that optimizes all of these things, but really focused on how do we actually get really good evals for search, and then we can do all these optimizations for you if you're not a specialist in the space. Cool. I guess anything else on what you're seeing with multi-agents or multi-steps? Like, is there a length of number of steps where it's like the error is just compound enough where you're like, wow, like this is definitely going to break? Or can you, kind of just run infinitely long workflows? Now, I know like Claude Code, for example, breaks things down into like a sub agent that goes off and like does something. They also have a lot of tricks, as you mentioned, that like kind of compress what happened in the previous whatever X number of lines of output into something smaller to preserve context window. I don't know what you're seeing in terms of like people running super long work and long-standing workflows, or is it just break it down into smaller sub agents?
generally the more you can decompose a problem, the better the outcomes are in kind of like the current way agents work. And I mean, right, you see that with Cloud Code. You see the output where it first creates a plan, right? It has the to-dos, and then it goes and does stuff and updates the to-dos. But the back and forth, I think what really unlocked like a bit of a productivity boost for me using Cloud Code was having better designed unit tests that are more fine-grained, that it can call more often and get that feedback loop of, is this code performing well in the parameters that you as a like human are trying to design it to work well in. So that includes things like speed optimization, right? Like you want to have a unit test that's like, oh, I require it, the search result to come back in under, 500 milliseconds, 300 milliseconds, whatever you want. That should be a unit test as well. So it's like getting that feedback of, hey, this is like an inefficient implementation I'm going down, right? Like you want to be able to break it out from a poor path of coding as quickly as possible. That's really how you get the best result in these types of tools. But back to the long horizon problem, like, yeah, there's I think I forget whose paper it was, but there was a paper relatively recently that it might have been from Microsoft, of showing that after n number of steps in a turn-based conversation, the quality of the answer and final output degrades at a pretty dramatic rate. And it was after it was, I think, less than 10 steps in like a multi-turn conversation. And I think this kind of like follows practical engineering guides I've seen of people using language models, where you want to restart often. Like anytime it starts to go down a bad path, you want to reset that context. You don't want it to actually have that bad kind of like path in that context memory, because that's going to kind of bias it towards that line of thinking again. So any time where things start to degrade, like you want to try to purge that as quickly as possible, whether that's through unit tests and coding systems, or other ways that you can just like restart that chat system or restart that chat process the second you see it go into like this degradation path. That's generally how people are working in a more complex like agentic loop system. But it's very true that once you have that context start to be in an area where the language model is starting to degrade stuff, like that it goes back to that principle of like, you're trying to make that highest quality signal in that context. Like that's really the key for everything. And the second you have something that's like going down the wrong path and that stays around in the context, then you're gonna be kind of stuck in this worse space.
I'm actually curious. I've asked this question to a couple people, but LangGraph has like the DAG representation that they made undagified, so like it could actually be like a cyclic DAG now. So it's directed cyclic graph potentially. But there's kind of like the state space representation of agents. But then people have been saying like, if the models get smart enough, like maybe these were just scaffolds and they can just kind of fall away and we didn't need them. I'm actually curious like what your opinion on this like is. Do long term we need that type of scaffolding, or will it just be like throw in the prompt, like everything is model?
Yeah, I mean, you see that everything is model mirrored in just training of these models too, right? Like the fact that you can throw a bunch of data at a really large neural network and have it learn something, that's just everything is model in that case. But the like scaffolding, I kind of like akin to this decomposing of the problem. And really, like everything can be model if you have a sufficiently large model and sufficiently long time horizon and training like budget. I am of the mindset that you can learn pretty much anything, but I would say data efficiency doesn't work that way in the real world. And if you're trying to make a reliable system and productize any of this stuff, I'd say that degree of scaffolding is always going to exist. You're always going to try to like, how do I imbue as much of like the best knowledge and best practices I can into this system to make it reliable as possible? And that includes adding the scaffolding is kind of like that guardrails of like those validation points, right? Like the scaffolding adds those unit tests. The scaffolding adds kind of like this validation with other humans, whether or not the current path that this agent system is working in is doing the correct thing or not. So like I always see that as being valuable. And at the end of the day, even if everything can just be trained without that type of system, like it'll be much, much more data efficient to have that type of system in place. And you're going to have a higher likelihood of a better product being built, rather than just kind of like the pure research aspect of like, oh, is it possible to learn something that can, just do the right thing in the right own, like it learns its own state space model, what's going on and all that. It's like, maybe, but like, why not just give it that benefit from your own expertise to begin with?
And I think that's a good point. Like the reliability that's actually needed to trust it with enterprise tasks is probably very different from just everything is model, which like in a theoretical philosophical world might be the case. Between the coding agents we mentioned, Claude Code, Cursor. I don't know if you've tried any of the other ones like Codex, Jules, Windsurf. Like, who do you like? Are there differences in the approaches people are taking? Have you had better experiences using any of the coding agents over any of the other ones, or what is your primary tool set today?
I mostly use kind of like my own wrapper on the OpenAI API as well as Cloud Code. I tried Cursor, I want to say like a year ago, but haven't looked back since because I didn't want to get a new IDE basically. So yeah, the Cloud Code.
Are you a Vim person?
No, I'm
Okay.
JetBrains, so I like PyCharm. But
Because I feel like
yeah,
the people who were like
yeah.
Vim people are all went to Claude Code because they were like, like, we like this
Yeah,
CLA. We like that it's still here in terminal.
I mean, that's the way it works well with PyCharm. And actually, also GitHub Copilot, right? Like that's enabled. I use that too. Great for smaller snippets of boilerplate that's going on. I'd say ultimately, like, the success doesn't necessarily come from model quality, but it does. It's just like the time taken to get to success. The starting out, the best way I used it was for breadth of brainstorming, right? Like getting ideas of how to approach problems in like as much like of a diverse way as possible. Because like that's something that humans are bad at, right? We're super biased and like anchor on to certain thoughts of approaches, as well as like we get fatigue, right? Like trying to think of, what would be a new possibility? What would be a new possibility? That's something that humans are bad at. But language models, one of their best use cases is like, what do you think you can do with something that you can just like throw, an infinitely parallelized like form of producing like differences, throw that at a problem and see what happens. So in the case of like brainstorming partners, it's really, really good to like see like maybe approaches to architecture that you wouldn't have thought of. Secondarily, so I've been using like reasoning like O3 models for coding help for a while, where it's like a lot of copy paste back and forth. Like when I got Cloud Code setups, especially with like it running the like a test suite that helped generate the test suite, as well as me fine tuning this test suite, getting that feedback loop in, that really unlocked a lot of productivity. Giving it that feedback, because otherwise it would have been me copying and pasting the output of results into different windows, and it's just slower. But the ultimate quality is pretty much the same, right? Like the quality I'd get out of like O3 High from that process, even though it's much longer, is kind of the same. It's like, just can you get the coding agent to go down that right path and not like start to get down some weird area and restart as often as possible to do that. So yeah, best practices like brainstorming partner, create a plan for the code, help refine and write unit tests so you can get that feedback loop. And then once you have that feedback loop going, you can start to let a little bit more of the like Cloud Code agent go on it. And once you see it start to create diffs that you're like, that's like starting to do something weird, like stop, like restart the process with like the last checkpoint that you liked in the code, which you should be git committing like in a very fine-grained level, so you can roll back to these types of checkpoints as quickly as possible. That type of thing generally gives the most success. So short feedback loop of tests and resetting to states that were kind of like before divergence, where you noticed something going weird in the code.
It does, like, I've been using Cursor. I've done a little bit with Claude Code, but it does, like, it goes off the rails sometimes, especially with like really large code bases. Like I've noticed it will like generate a ton of files and you're like, oh god, like why did it generate so many files? Or like in very large, if it's dealing with huge JSONs and stuff, it gets totally lost. Other places it's like it'll duplicate code, and the other thing is like it's actually really bad with file structures. So if you're like in the outer folder versus the inner folder, or like it like constantly forgets to just like turn on the virtual environment or whatever, and so you get all the Python 2.7 errors. So there are lots of like those types of things that are kind of icky I find when I'm coding that kind of like take me out of the flow a little bit. It is like really interesting to see, like it can generate a lot of code. The code is not always the best. And so I still feel like we're not quite there in terms of, automate all the coding. I do also approach it with a little bit of sadness because as someone who like studied computer science and was like, you're like an artisan, and the things that you kind of took pride in are like slowly getting eroded, which is perhaps how the artists feel as well, with when they see like their style totally stolen by Sora or Dolly or whatever.
Yeah, yeah, that's interesting. I do wonder if it's similar to kind of like the artist situation, but like I do feel most of the code still requires tweaking and like cleanup after the fact. Um, I've yet to have something just produced that I'm like leaving the file alone with after. Like that's just not happened yet.
Well, I mean, Marcus, we talked across so many different subjects. It's been amazing, and I thank you so much for spending the time. It's super, super fun to chat with you. You've been in and around like AI and ML like before the current wave, so I think you actually have like a lot of perspective that is beyond just the transformer architecture that we have today, and the Gen AI wave that we've seen, which so you're like truly an OG in the industry, and we're just so grateful to have been able to just tap into your brain for a little bit. So thanks.
Yeah, thanks so much.